So let's talk about binomial theorems. When we take a plus b, which is a binomial, and take the power to 2, 3, 4, and whatever number you want to use, we can expand it out like these. And a key pattern that you'll see is that it actually follows something called the Pascal's triangle right here, where the coefficients match. And you can probably see that 1, 1 matches with 1, 1 here, 1, 2, 1, 1, 2, 1 here, 1, 3, 3, 1, 1, 3, 3, 1 here, and so on and so on. And that's the important observation. Now, recall the formulas that the general expression and sequence of a binomial to the nth power is this, the sigma notation nk a to the n minus k times y to the k. And to figure out the r plus 1th term inside of any binomial sequence is this. So let's look at an example right now. Let's take a look at this question. The question asks, find the coefficient of x to the 4 in the expansion of 2 plus 3x to the 7. So as discussed before, when we're trying to find the coefficient in front of a single term, we like to use this formula. So t subscript r plus 1 equals nr a to the n minus r times y to the r. So the key here to finding out what the value of r should be is to first just list out what we have. So we have t r plus 1, and in this case n is equal to 7. So we'll put 7 and r, and then a is equal to 2, and it's going to be 7 minus r, and then y is going to be 3x to the r. And if we're interested in finding the coefficient of x to the 4, all we have to do is say, okay, that means this r must be 4, because we want to get the x to the 4. And that's how you should be getting the value of r every single time. That is probably the simplest way to do so. So we know that r has to be equal to 4. And this becomes 7, 4, 2, 7 minus 4, and 3x to the 4. And as you can see here, we get 7, 4, 2 to the 3 times 3 to the 4 times x to the 4. So again, we confirm that we are very happy because this is going to be the coefficient of x to the 4. So to evaluate this, you can say that it is going to be equal to 22680 x to the 4, and therefore the coefficient is equal to 22680. So let's try another question here where it says find the positive value of n such that the coefficient of x squared in the expansion of 1 plus x to the n is 45. So again, we're given the coefficient in front of x squared this time. So let's use the formula again. So tr plus 1 equals nr. And this time we don't know n or r, so we're going to keep it there for now. But we do know a and y. So this is going to be 1 to the n minus r and x to the r. And right here, it should be pretty obvious that r has to equal to 2, because we are trying to find the coefficient in front of x squared, so this must be 2. So we can say r is equal to 2. And we can also recognize here that 1 to any exponent is always just going to be 1. So we don't have to write that down after. But we do get x squared. So this becomes n2 and x squared. And now we are given that this coefficient in front of x squared is equal to 45. So let's use that. Let's say 45 equals n and 2. Now, this becomes n factorial divided by 2 factorial divided by n minus 2 factorial. And this becomes n times n minus 1 over 2. And let's expand this out. And this becomes n squared minus n minus 90. So this becomes n minus 10 times n plus 9 when you factor it. And therefore, n equals 10 or negative 9. But The question above here says that we're trying to find the positive value of n. So we have to reject the negative number. And therefore, n is just equal to 10.